I wanted to go through some basic terminology which will help you to understand the slides we're going to see. This is a typical section through the project. It is a mixed face tunnel, which means partially in earth and partially in rock. The earth portion is supported by means of various methods of supportive excavation. We have already covered that material. On this project, the earth portion was typically supported by soldier piles and lagging or secant pile walls. That upper portion was braced by pipe struts or rock anchors or some combination of those two. So much of that material has been covered, and you will see applications of it again on this project. The lower portion was in rock, and the rock was removed by drilling and blasting. Whenever you see a typical section like this, the rock is shown to be removed as if by magic with some kind of a laser. It's removed exactly sufficient to construct your structure inside. And I must say, I made this drawing myself, and I repeated that same peculiar notion that you can sculpt the rock excavation to fit your structure perfectly. Of course, in reality, it's nothing like that. The rock is removed by drilling and blasting, and naturally that's done with great care and great control. You certainly want to minimize the amount of rock excavation because it's very costly, but at the same time, if you don't over excavate, you will find tight spots, which means you have to return and somehow chip out those tight spots to provide enough space for your structure. So now I've drawn a typical section which is a lot closer to reality and shows the rock over excavated. You also have to be extremely careful that you don't over excavate it to the point where it may undermine the supportive excavation of the earth layer above the rock. Very difficult to control exactly how the rock is going to split. There are procedures of line drilling, pre-splitting to ensure that you do not undermine the earth layer above the rock. But in general, you will get a picture that looks much more like this as opposed to that theoretical look that you'll see in textbooks. Now, how do you accommodate this area which has been over excavated? We have already seen an illustration in the video of a mud slab. So after you have completed your excavation, you pour the mud slab. The mud slab is always an event to be celebrated because it means you have gotten all the way down to the bottom of the hole. You've overcome many problems and encountered many surprises on the way down, but you've managed to solve all of those, and only after you've solved them can you pour the mud slab. So the mud slab is a good time to take a deep breath, pat yourself on the back, because you've accomplished the most difficult challenges of the project. Very often the structure you're going to build is a simple concrete box, and that becomes really the easiest part of the project, although the design documents focus very much on the finished structure. They are relatively silent on all of the construction issues. So to fill out that over excavated rock area, you begin with a mud slab, and that evens out the bottom and allows you to continue the construction on a solid surface. but you must also even out the walls, and that is done with a sand wall. Sand wall is also a concrete wall. You have to put up a single face form and you fill that space with concrete, and that's called a sand wall. Typically you apply the waterproofing over the mud slab and the sand wall, and then you're ready to construct the new structure. Now, I've mentioned waterproofing from time to time because it is critically important in an underground structure, but it's a very large and complex subject. It goes way beyond this class, but nevertheless, the need to do it correctly is worth reinforcing during this class. The process being used here on this project and on the earlier project showed concrete being placed up against a waterproofing membrane. That membrane has to be perfect because any penetration of that membrane will create a path for the water in your permanent structure. Earlier in my career, it was done a little differently. The waterproofing was applied to the mud slab and the sand walls, but then it was protected by a 4-inch protection course of concrete. In earlier construction, that protection course might have been brick. So it was understood that you needed to do a perfect job on the waterproofing membrane, and then it was prudent to cover that membrane so that it could not be damaged or abused in any way during the subsequent construction. That's a very careful belt and suspenders approach, which in the case of waterproofing, I think pays off. So I wanted to point out to you again, this is a complex subject, as something for everybody to focus on during the design, and especially in the execution and inspection during the construction. No, that is not me on the right-hand side of the photo. I do like the outfit he's wearing. Looks like he's in a suit and a tie, and that's not a hard hat, but looks like pretty handsome fedora. So he looks pretty good on this photo. And he is not doing the waterproofing. He looks like the guy who comes down and checks it out. The waterproofing is many, many layers of rolled out material overlapping, and that will then be covered with a protection course of either brick or concrete or some combination of the two. In the background, it looks like they're covering it with a concrete slab, but going up the walls, traditionally they would cover it with brick. This photo is about 100 years old, and my guess is this tunnel still has no leaks. Here, some membrane of waterproofing has been applied to the floor, and it is being protected by layers of brick. The brick here is set in mastic, which is a kind of an asphalt material. So you have a mud slab, some kind of a membrane, and then multiple layers of brick and mastic, which protects the membrane and at the same time provides a waterproofing in itself. And a similar treatment will be carried up the side walls.